So now that we have a basic idea of how equations work, we're going to want to move into more complex equations such as inequalities. Now we all learned what inequality symbols were back in like first grade. So we have greater than symbols, less than symbols, and equal to symbols. This would mean that for the greater than symbol, 5 is greater than 4 because it's more than 4. 4 is less than 5 because it's less than 5, and 4 equals 4 because they're the same value. But what if we put in a variable? If we put in x into each of these, what would x represent? Here on our first example, we have x is greater than 4. So we know that on a number line, if we have 1, 2, 3, 4, 5, we know that for x, it's going to have to be greater than 4. And it's not equal to, so we put an open hole, and then we would have it going to the right because it's greater than 4. That's what x would equal. In this case, x is less than 5. We'd have the same number line, and again, it's not equal to, so we're going to have an open circle at 5, and we know that it's less than, we're going to the left. So x can be any of these values, whether it's a whole number or an integer. And then of course we have x equals 4, which on a number line, wherever there is 4, we would just fill it in because we know it's definitely equal to 4. That's the only value that we can sub in for x. Let's look at our first example. So here we have 5x plus 10 is greater than 20. The way you handle this is by first treating this equation like it's just a regular equation, not an inequality. So imagine this greater than sign is an equal to sign. So we have over here 5x plus 10. We're still going to keep that greater than sign. We're just going to imagine it's an equal sign. Now we have to isolate our variable. So we get rid of the 10. Always subtraction first. So we have 5x is greater than 10, and then we divide out the 5. And then we're going to have x is greater than 2. So, now that we know that x is greater than 2, we have to plug it in on our number line. We know that we're at 2, but it's not equal to, it's just greater than. So because it doesn't actually equal 2, we're going to put an open circle at 2, and because it's greater than, it's going to the right because the value is going to have to be larger than 2. And that would be our number line for x. And the way you check if you're correct is by plugging in any value that is greater than 2 into our original inequality. So let's do 3 for example, the next highest one. If we have 5 times 3 plus 10 is greater than 20, 15 plus 10 is greater than 20, 25 is greater than 20, that checks out. And any value greater than 2 is automatically going to check out, even if it's a value like 2.1, which is only slightly greater than 2. First we're going to divide out our 6, and we have x minus 5 is greater than or equal to 5. Then we have to add 5 to get rid of it. So then we have x is greater than or equal to 10. Now, because this is greater than or equal to, we know when we fill it in on our number line, it's going to have to be a solid circle because it actually equals 10. So we're going to fill in our solid circle on 10, and because it's greater than, it's moving to the right. So when you're doing your check, if you plug in 10, minus 5 is 5. 6 times 5 is 30. It meets our requirement. 30 is either equal to or greater than 30, so it checks out. And if we do anything bigger than 10, so let's say 15, minus 5 is 10 times 6. 60 meets the requirement of greater than 30. So this checks out. Here we have another example of an inequality, except we're not using a greater than or less than or equal to sign. We're saying that x cannot be equal to a certain value. So again, we're going to treat this like a regular equation, treat this like an equal sign. We're going to isolate x, subtract 8 first. So then we're going to have x over 3 is not equal to 1. So to get rid of the fraction, we're going to multiply each side times 3. So we know that x cannot equal 3. That means x can equal any other value that's greater than 3, any value that's less than 3, just not 3. We don't know what value equals, but we can determine from this that it doesn't equal 3. The way you write this on a number line is just like when we have, let's say, x is greater than 3, x does not equal 3, we put an open circle. In this case, because we're not talking about it being greater than or less than 3, we only put the open circle, and you're done just like that. Hey, thanks for watching this CrashCore video. To watch the previous video in this series, click here. To watch the next video in this series, click there. If you want to request a video, make sure you put it in the comments below. And don't forget to subscribe and like this video.